Okay, so this is lesson 3, kinetic energy. So the other type of energy. So remember back in the last unit, everything that's moving has a property called inertia that wants to resist its state of motion. Because of that, you need to apply a net force to change something's motion, which means it takes work to get something moving and to stop it moving. In fact, as you may remember from the level 3-4 project, it takes exactly the same amount of energy to get it moving and stop it moving. So that implies a moving object has some energy caused by its inertia, and that an energy depends on both the object's mass, a heavier thing has more inertia, and its velocity, a faster thing has more inertia. So, how does it work? Well, let's think about throwing a ball. If you're throwing a ball, you need to do some work on it. So, work is force times distance. It's also the change in energy. So if force is mass times acceleration, basically you've got a ball, you're applying a force, it's starting at a V1 of 0, it's ending at a V2 because you've done some force through some distance, which, when you're throwing a ball is called your wind-up. If you actually throw those two equations together and do a lot of algebra, which I'm not going to do now because it's in your textbook, you end up with a value for change in energy that it simplifies to a half times the mass times the velocity squared. So this is what we call the kinetic energy. M is the mass in kilograms, V is the velocity in meters per second. Energy, for example, let's say you throw that ball and now it's traveling at 28 meters per second and you want to know how much kinetic energy it has. Well, the velocity is 28 meters per second. The mass of the ball is 0.2 kilograms. Important thing, you've got to use meters per second, you've got to use kilograms, otherwise you are not going to get a kinetic energy, or EK, in joules, which is what you're trying to find. So, the kinetic energy is 1/2 the mass times the velocity squared. So, it's 1/2 of 0.2 times 28 squared, which works out to, by the way, a good way to put that through a calculator, instead of putting in half, just put in 0.5 times 0.2 times 28. Don't forget to square it. That's the most common mistake people make. And you end up with an energy of 78.4 joules. That means you had to do 78.4 joules of work on that ball to get it moving, and it can do 78.4 joules of work on someone else as they try to stop it. Another thing we can do is we can look at the change in kinetic energy. Now, unlike the change in gravitational energy, you can't just subtract the velocities, okay? You can't just say 90 minus 60, so it's a change of 30 kilometers an hour, change that to meters per second, plug it in. Because remember, the velocity is squared, so 90 squared minus 60 squared is not the same as 30 squared. So because you're squaring it, you have to find both. So if you want to find the change in energy, remember that's the final energy, E2, minus the initial, which is E1. So the final kinetic energy is 1/2 m V2 squared minus 1/2 m V1 squared. Apology for the handwriting. So it's 1/2 of, we got to convert 90 kilometers an hour divided by 3.6 is 25 meters per second. And 60 divided by 3.6 is 16.7 meters per second. So it's a half of 1500 times V2, which is 25 squared minus a half of 1500 times 16.7 squared, which if you throw through your calculator, 0.5 times 1500 times 25 squared minus 0.5 times 1500 times 16.7 squared equals a ridiculously large number because I made a mistake. 0.5 times 1500 times 25 squared is 46,750. Let's write that down. 468 750 minus 0.5 times 1500 times 16.7 squared is 209. 167.5. So your final answer, the change in energy, how much you need to give it is 259,582, or to the two digits we've got, 2.6 times 10 to the 1, 2, 3, 4, 5 joules. We could also do it slowing down. So if the car is slowing down from 60 kilometers an hour to rest, you have your your change in energy being the final energy E2 minus E1. So a half mv2 squared, which by the way is going to be 0, minus a half mv1 squared, which is a half of 1500, don't forget the negative, times 16.7 squared, which is 0.5 times 1500 times 16.7 squared. $209,000 minus or minus 2.1 times 10 to the 5
Mr.
joules.
Wyatt, please take line 2. Mr. Wyatt, line 2.
See, even the YouTube version of me gets interrupted by announcements. Okay, so the reason this is negative, why that's important is if you're slowing down, you're losing energy. If you're losing energy, you're getting a negative number. All right? Gaining energy, an object gaining energy will give you a positive, an object losing energy will give you a negative. It's a great way to make sure you're right. All right, that's it.